the June 2011 paper 6 variant 2. And the second question says, in Scotland in November, on average of 80% of the days are cloudy. So 80 by 100 of the days, D, are cloudy. Assume that the weather on any one day is independent of the weather on other days. Use a normal distribution. Now this is part 1. Use a normal approximation to find the probability of there being fewer than 25 days, 25 cloudy days in Scotland in a November 30 days. So November has 30 days. So when they say that 80% of the days on average are cloudy, you know that 80 by 100 of 30 are cloudy, so that would give you 24 days on average, and so your average, your mean number of days would be 24. Your probability of success, that in this case you would use the binomial theorem and a combination of normal distribution too. So your probability of success in this case is the probability of it being cloudy. The probability of failure is the probability of it not being cloudy. So in this case, you would get 4 by 5 or 80 by 100 as the probability of it being cloudy. Now, how do you get this? You use the same formula that we talked about in the last lecture. That is, NP is equal to the mean. So you know our mean is 24. So N is 30 because there are 30 trials or 30 days in which we're investigating this or experimenting this. So it's 30 into P equal to 24. And you get P equal to 24 by 30, which is equal to 80 by 100 or 4 by 5. So P is equal to 4 by 5 and Q is just 1 minus P, because as we said earlier, Q plus P is always equal to 1. So Q is equal to 1 by 5. Now, keeping this information in mind, it says use a normal distribution or a normal approximation to investigate the probability of there being less than 25 days cloudy. Now, if we were to use a binomial distribution, that is the formula NCR, Q to the power of N minus R, P to the power of R, and start with there being 1 cloudy day, then 2 cloudy days, then 3 cloudy days, and go so on to 24 in this case cloudy days because it's less than 25, we would have to add up all these probabilities. But you see how strenuous and time-consuming this would be, as this is not an efficient method. So statisticians have developed another method using the normal distribution. And here's how it goes. So once you have the probability of success and the probability and Q, the probability of not success or failure, in this case 0.8 or 4 by 5, and 0.2 or 1 by 5. And now it's important to find the standard deviation SD. And here's a good formula for it. It's equal to root of NPQ. So in this case, our standard deviation would be root of 30 into 0.8 into 0.2. And this would equal to root of 4.8. That's our standard deviation. Now, when it says less than 25 days, I think I'll erase this page because we need this information over here. I'll just erase this page. I hope you got this. Now, when it says less than 25 days cloudy, statisticians have developed a 0.5 allowance. In this case, it would be 25 minus 0.5. When it's less than a number, you always take 0.5 less than that, because if you take 0.5 more than that, that is 25.5, you would this is obviously greater than 25, so it would not be included in this normal approximation. Let me put this in a graphical method. Now you have your mean here. This is this regular bell-shaped curve. You have the mean over here. That's your mu. I'll just draw the bell-shaped curve. And this as usual is asymptotic. That means it nears the x-axis but does not touch it. And you have your standard deviation in anywhere in a place like over here. But now, when you want to find the area less than 25, suppose 25 is over here. This is 25. You want to find the area less than that, that is in this direction. So you would want to find this area over here, up till infinity, minus infinity. Now, statisticians have developed a 0.5 allowance, that is adding or subtracting 0.5 when necessary in this, when converting binomial theorem to normal distribution. Now this 0.5 only applies when you're converting binomial to normal distribution. If you add 0.5, your 25.5 would be somewhere here, and you would get this extra area which you do not want. You do not want this area. You would want something less than that. So you would subtract 0.5 from 25, and you would get 24.5. Now, using the equation of normal distribution, that is z is equal to x minus mu divided by standard deviation. Now here x is just the number of trials we're trying to find. It's just like r in the binomial distribution, except in this case it would be 24.5 is our x. Mu is our mean that we found earlier. Mu was the mean of 24, and standard deviation is just root of 4.8. So we would want to find our value of z, in this case would be 24.5 minus 24 divided by standard deviation is root of 4.8, and this would equal to, let me just calculate this, you would get 0.5 on the top divided by root of 4.8, and your answer would be 0.228. Let my cursor come back. Okay, it's back. 0.228. Now I'll take it to three significant figures, because on the table that we have in our statistics textbook, on the table, I think it's on page number 172, the z values on the left hand side, they go up to three significant figures. So in this case it's 0.228. You would go to 0.2, then you would go to 2 on the slightly right hand side of the book. You would get 0.5871. Look for that value there. So it will be 0.5871 plus, you would add another value, that is 8 in this case. So that will be 31. So 0.0031. Remember, when you're adding that value, you would add it to the last two digits that you have in this original value that you got. In this case, it's 0.5871. And when you add this, you get 0.59. Is it 9? Yes, it's 902. So 295. So your final probability, that is the probability of it being of the number of cloudy days being less than 25 or fewer than 25, is 0.5902. I hope you see I got that there. Let's review now. So what we did first is we had to convert the binomial distribution to the normal distribution. How did we do that? We had original P, which was 0.8, Q, which was 0.2. We found our mean, which is 24, because it was 80% of the 80% of the days in November were cloudy days, and we could use NP and NPQ to find the standard deviation. And once you have the standard deviation, now we use the now here's the confusing part. We need the number of cloudy days to be fewer than 25, and we want to find the probability of that. Drawing it on this bell-shaped curve, I hope you remember this normal distribution bell-shaped curve. We have our mu in the center over here, and we have 25 over here. So the area we want to find is less than 25. That is all this area. Now, we want to find the area less than 25, so we take a factor, that is the 0.5 factor. Now, this factor is not, this factor statisticians have taken it. No one knows why. So don't break your head over that. So now that you have 25, now you cannot add 25 0.5 to 25, because that would take some extra area over here which is redundant or unnecessary. So you would take 0.5 less, that is 24.5, and that is your value of x. Now x in this case is on this axis over here. Your x is on this axis, and you can find less than or more than. Now suppose they asked a question where they said the number of cloudy days has to be more than 25. That means greater than 25. So here you would take 25.5, you would add 0.5 to 25, because if you subtract 0.5 and you have 24.5, you would have this unnecessary area. So in this case, if you have 25 over here, the area that you want is just greater over here. This is the area that you want. Now, if you subtract 0.5, you would have this unnecessary area over here that I'm shading in right now, and that is redundant. That you don't need. So you would add 0.5 to get 25.5 and do the work that way. Now remember, in your normal distribution table that you have in the back of your textbook, it always finds the area to the left of it. So if you want less than 25.5, if you want more than 25.5, what happens is, if you find the value on the table, it would give you everything less than 25.5, and you know that the total area in a normal distribution curve is always 1. So therefore, you would do 1 minus that area, and you would get the area more than that. I hope you understood this part. I'll move on to the second part because I think it needs the first part. So the second part says, give a reason why the use of a normal approximation is justified. Now that there's two key points to understand over here. I'll just clear this page. We don't need this. Now, earlier in the last part, we found what NPQ and NP were. Actually, we found what we found NPQ and NP were. NP was 24 and NPQ was root of 4.8. It was 4.8. Root of this is just the standard deviation. Now, when you use a normal distribution, NP has to always be greater than 5, NQ has to always be greater than 5. These two have to be satisfied. Otherwise, a normal distribution cannot be used. So NQ in this case is just 0.2 into 30, which is 6. Now 6 is greater than 5, and NP, which was in this case 24, and P, which was 24, is greater than 5. Since these two are satisfied, this gives us a reason to use the normal distribution. If this was less, if any of them were less, we cannot use the normal distribution. We'll have to do it manually with the binomial distribution. I hope you understood this lecture. If you didn't, it's kind of confusing, I know. It just comes out of a lot of practice. Just do many problems and you'll understand the concept. If you have any questions, email me.